We're going to look today at interpreting a chemical formula. We'll do this by working through 5 examples together. You might want to make notes as we go along, or maybe have a look at the end. So we're going to have a look first of all at example number 1, SO2. SO2 is sulfur dioxide. Notice it's a capital S and a capital letter O with a small subscript 2 after the O. And what we mean by subscript is if this was the line I was writing on, that would be a small number that's halfway between the line above and halfway between the line below. So what would be worth us doing is just underlining the individual elements that are present in it. So we've identified that there's some sulfur atoms in it and there's some oxygen atoms in it. So in this case, there's sulfur. There is no number immediately after the sulfur, so there is 1 times sulfur atom present in this molecule. And then if we look at the oxygen, there's the oxygen. It's a capital letter, so it's a single letter element. Immediately after that, there's the number 2, so there are 2 times oxygen atoms present in this molecule. So let's have a look at one where we've got a 2-letter symbol. So this is a form of cobalt oxide. Let's underline the atoms first of all. So I'm going to underline this 2-letter symbol. It's a capital letter and a small letter after it, so it's a 2 symbol element. And then I'm going to underline the oxygen after it. So CO, you'll need to have a look at your periodic table, or maybe you know this, but CO is cobalt, and there are 2 cobalt atoms in this formula. How do I know that? Capital C, little o, so that's a 2-letter symbol. Immediately after it, there's a 2. So that 2, that number there refers to the element written just before it. It's sort of a little bit backwards. Cobalt, there are 2 of them. Oxygen, there are 4 of them in this case. So 4 oxygen atoms. And of course, hopefully we would realise that this would, like the previous one, this would be a compound because there are 2 or more different types of atom present. Let's have a look at sodium hydroxide. So this formula, capital N, little a. So that is an element symbol. This will often be a situation where people might make a mistake. They'll look for an element OH on the periodic table, but actually there's 2 elements there. There's O, and then there's H. So these are 2 separate elements. So having done that, and we'll find on the periodic table, maybe we know that Na is the symbol for sodium. So there is 1 sodium atom here, 1 oxygen atom, and 1 hydrogen atom. Okay. Now we're going to come to a slightly more complicated example, and this is going to be CaSO4, and this is often where someone will make a mistake. People will often look for SO4 on the periodic table, but obviously there's 2 elements there. So let's do the first stage again, which is underline the elements present. Underline Ca, it's a 2-letter symbol, and then we've got S because it's a capital letter, and then O because that's a capital letter. So there are 3 different elements present here. And then we've got 1 times calcium, 1 times sulfur atom, and then here we've got 4 times oxygen, and that's calcium sulfate. Okay, so we're going to have a look now at 2 examples with brackets in them. Okay, so both of these examples are going to have brackets in them. You'll see later on why we need to use these examples, why we need to use brackets, but for now we just need to interpret them. So this is the formula for calcium hydroxide. magnesium hydroxide, or it will be in a moment. So magnesium hydroxide. So let's work out what's happening in magnesium hydroxide. First of all, we've got a nice straightforward one. We've got our magnesium atom here. But then we've got O and H, and that's an element on its own, and that's an element on its own. But they are in brackets, and there's a 2 immediately afterwards. So a way of thinking about this is actually to go, there are 2 OHs present. So if I then write this out like this, what that then means is, in total, there are 2 times oxygen atoms here, and 2 times hydrogen atoms, as well as the 1 times magnesium atom that I've got there already. Okay, so another way of thinking about it is the elements inside the brackets are multiplied by the number outside the bracket. There was 1 oxygen and 1 hydrogen, but I've multiplied, there's a 2 outside, so there's 2 oxygens and 2 hydrogens. And our final example, probably our most complicated one on here today, is the formula for magnesium nitrate. So this NO3, and I'll just write that there, we don't need to know, that's not part of the lesson today, but it's always worth checking that NO3 unit, if you ever see NO3 together, then it's a nitrate. So let's do what we've always done, underline the atoms. Underline the 2-letter magnesium, underline the N, underline the O. So first of all, no issue there, there's 1 magnesium, there's no number immediately after it. Let's have a look at inside the brackets. Let's write it out like we did last time. We said what that actually means is, rather than 1 NO3 unit, there's 2 NO3 units. So I've underlined the atoms again. So in total we can see here 2 times nitrogen atoms, and then 3 and 3, which means 6 times oxygen atoms. So I write that so you can see that. Again, we could have looked at the previous one. We could have saw here that nitrogen, we've taken this, we've multiplied everything in here by the number outside the brackets. Thank you very much.